urchin. I can come in a little bit more.
It's okay.
That's it.
Oh, just kidding.
We'll settle out here in a second. Little piece of
Bridge
bamboo
now.
back there.
I don't know.
You can add that step. Thank you.
Help us out, Shore. What are we looking at?
Got a bunch of little white lumpies.
I'm not even sure about what's the top and what's the bottom.
Ugh. Well,
I think
that's
we're looking at
bouncy.
the
Okay,
bottom
sorry, Ed.
of some type of star.
Hopefully they got what they're looking for. I'm just running into stuff over here.
Yeah, no worries.
All right, got to move.
Ooh.
Oh, Iridogorgia.
Yeah,
Yeah.
it's big.
Wow, that's a big one on the right.
Yeah.
So Emil, what are your thoughts in terms of how old this seamount might be?
In the vicinity of like 74 million, give plus or minus a few million.
So more or less the same age as Howland and Baker?
That's my guess, that it's pretty close to the same age, a little bit older than Howland maybe, just because it's further north and it seems like the hot spot traveled south. That, you know, the hot spot that
There's a big tall thing.
created the Tokelau seamount chain. Yeah, that is a tall one. But hopefully so the basalt samples we gathered will help answer that
Holy
question.
Man.
Yeah.
That's tall.
That's, what, is that 3 meters tall?
Could be.
Let's see, the Herc view might. That's hard to tell from the Argus view.
Maybe not, maybe 2 meters tall.
It's a big bamboo.
Ooh, maybe not, I don't know. Hard to say. Maybe it's Herc height.
One Herc.
One Herc.
So at that time, 74 million years ago, that was before India collided with the Asian continent.
That's crazy
The Atlantic,
to think about.
yeah, the Atlantic was still opening to its present extent.
Truman was in the White House.
Have you got any input in terms of what that sea star might have been?
Maybe a sea star eating a bamboo coral, not sure a species of the star from Meredith. But it sure did have a puffy, I think we were looking at its bottom.
Oh, so maybe it was ejecting its stomach?
I don't know that sea stars.
Some of them kind of like...
That's a pretty big stomach.
Yeah.
Yeah, it was...
I thought that the
I don't
bottom
know,
was
I'm
the
trying to
part that was
figure
attached
out.
to the coral.
Huh.
Like it was like that.
Oh, that was maybe the stomach
that
kind of
was eating.
extruding onto the... Huh.
And then the
What's
back
that
was the face, downward face.
I think that's just a bunch of brittle stars on that coral down there, giving it the pink look. All right.
We're going 352?
350.
It's pretty good so far. Like
We zoom on that guy on the right.
on the right. Oh, I see it there. Yep.
Yeah.
Camouflaged.
that same primnoid we saw, that we sampled?
Yeah, I think
Or
so.
similar at least.
Yeah. Caligorgia. Yeah.
Primnoid Caligorgia.
Okay, zoom in, please.
Coming in. And focus. Oh, it's further away. Huh.
It's quite far away, yeah. It's pretty flat here, so.
All right.
Are you happy?
Yep.
Okay. Thanks. Ooh.
Bridge nav. Add 1 step, please. Thank you.
George sounds different.
Yeah.
The radio's on and almost dying. On the bridge.
I got my radio's off over here.
Hmm?
Oh, we got a big one.
Yeah. Just take a look. Nice. Whoa. Yeah.
Keeps going. It's cool.
That's another bamboo, I think. I got several back here.
That one's almost completely stripped bare of polyps. There's one stalk left with polyps.
You're
Unless
right.
there's some that are closed.
Oh, maybe that's what it is.
Can't tell.
It's weird. Can we zoom in, please?
Yeah. I think.
Oh, it must just be closed.
Hmm.
Then open on this one stalk just above frame right now. I don't know what's going on there.
Don't either.
Yeah, it'd be strange for them to be closed like that.
Yeah.
Let's see what else we got up here. Another primnoid. Some more tall bamboo.
Think I can fit it underneath that?
Maybe you can try.
Nice looking rock over here.
Let's zoom in on those small rocks there.
Sure.
Interesting.
After this, I should start moving along.
Yeah, so the organisms that you see attached to the coral that look like feathers are actually crinoids. They're taking advantage of the influx of currents to be able to feed. All of these organisms are suspension feeders.
Okay, Ed, come on in.
Bridge nav. 1 step 20 meters, bearing 350.
Let's
Thank you,
let's,
Martina.
hey, Rennie, let's hold here.
Can you come down in your delta, please?
See if we can get some samples of these.
Bridge nav.
Want me to come out or you good?
We'll hold position.
Sure.
Thank you.
These
Well,
look like
yeah.
nodules, but I'm not an expert. But let's see if
Yeah,
we can
we'll
grab a
step back
couple.
a couple times.
Yeah.
Grab a couple or grab.
Well, let's see. Let's get a good bubbly looking one.
All right, we can do if we do it fast, we can do it without moving the ship back. So, which one do you want?
One that looks like it's about to hatch.
Right about there.
This one?
Anything in there looks good.
Do that again. Come on, work with me.
These just, they're nice and round.
There we go.
Where do we got space for this?
All right, I can move.
I think
Is
we're
that good?
fine.
I can move.
We don't have anything, and she can turn around.
I'm just thinking of this. I need to get pulled off. Do you want more than one rock from here?
I think that'll do.
Okay, then I might as well move.
Okay.
And let me know when you guys figure out where you want it. I recommend not slurping it.
In where?
What sample number
Forward,
is this?
yeah, forward bio box. Yeah, the port.
You see
Okay.
pins?
What is that? Yeah, that's okay.
Are these
Oh,
C
these
pens?
guys.
A lot of C-pens, yeah.
Wow.
Forest of pens.
Wow.
Pencil
There's
case.
there's a lot.
Yeah.
So we can put it in forward A. A little bit of the anemone might come out of B, but
Forward,
it's
forward left or forward right?
forward left.
Okay. I think we're gonna ditch those A and B terms.
Yeah, that's too confusing. We can't have two A's.
Yeah.
Reprint sheet.
Does the sheet say A and B?
It says
Yeah.
C
Yeah,
on the
sorry.
Yeah,
sheet.
let's get rid of
Saying
those
that.
letters.
What's the sample number?
083.
You could put underneath the forward push core. Put it in there.
Yeah, it would fit.
That'd be easy.
It'd be hard to do that while holding this. Take the push core out. Okay, so we're opening Pandora's box.
Yes.
Okay. I'm gonna sit down for that one then. And I'll open it just a wee schmidge.
Yeah, it seemed like a centimetered area. It was flat, and just it looked like a bunch of nodules to me.
Bouncy, bouncy. Let's hope for the best here. Okay, could you just crack that open, please? Oh my gosh.
Oh,
Maybe one
It's
more
okay
bump.
if a little bit
Look at that
floats
snowball.
out, because we've got enough. Oh,
Okay,
nice.
so
We've
awesome.
got
Nice.
enough for DNA from that. That's
that was a really round rock.
it was. They just looked different in appearance from the rest of the rubble.
Hmm. Okay, you want to keep moving?
Yeah.
I'm just gonna go 20 meters up.
Roger.
Bridge nav.
Up is 045 for me.
Stand by, sorry. What is that?
Up is 045 for me, I think.
I think.
Did you
yeah.
get a screen
okay, we
grab
can try
where we
that.
sampled
I don't know
that?
if it's a local high. You want to do 04520? Or let's
Sure.
just explore and get to the top and see where
Sure,
we're going to
sure.
go.
This looks like I'm seeing something in Argus, 045 as well. Straight ahead,
Yeah.
but nothing off to
No.
due north.
No. Yeah. It's plausible. Just don't want to move if we're already at the top, though. So. See
Yeah,
what-
you're right. That would be silly. Agreed. Egregious.
I think that's our, might be our final rock sample. That's 5.
Auto heading, that's why I'm not changing heading.
But if we call that a nodule, which I think we have a case for, then it's not 5 of the same type of rock.
this is the top?
Hmm.
No, not quite.
No, still going.
Still going. Okay, let's see which way that's going. If I wag all the way left.
Still that direction, so
So yeah, 015 maybe? What do you think?
1-5.
Or for me?
Yeah. So 3-0.
Yeah, it could be. I think we could get away with that.
Try it.
Sure. Yeah,
4,
I like
5,
that.
4. All right. Bridge nav. 1 step 30 meters, bearing 030. Thank you. I don't think there's much more to it regardless.
Yeah, I hear ya.
What do we got to the left there? Is that a
Let's find
that
out.
coral?
My guess is Primnoid Caligorgia.
Propeller?
Yep, that's a good guess.
This is the one you're talking about? Just left of the
Yeah.
lasers?
Yep, that's one.
Okay, go ahead, Ed.
All right. What's on it? Crinoid brittle stars.
Yeah.
Okay.
Okay, thanks.
All right, so you got 030 ordered up, so we'll kind of just come up alongside what appears to be the top. Maybe we're already there. I don't know.
Yeah, we'll find out. See if there's anything in sonars once we get up there.
And then it'll be almost due west. Well, we could kind of do a northwest then west. That probably doesn't matter
For,
to go to waypoint 4.
yeah, let's take a look.
We could just cut across there.
Just jump the gap, yeah.
Yeah.
Yeah, it looks not too bad. Unless you're interested in this flat part here,
Nah,
I think we should just go straight to it.
straight's good.
Okay.
How far are we gone so far on this watch?
Get him. I think we were just
Off the
past
wall,
there,
yeah.
right? Yeah. Elephant graveyard.
Think
Seem
so.
to remember that.
70
Yeah, it's good.
meters.
So we've gone around 550 meters.
All right.
Nice.
Look at that.
Look at that. Perfect.
Who said that?
10% ahead of schedule.
So when our samples come to the surface, do you find that they have a particular smell science? Or anyone that might want to answer?
Everything smells like the ocean. Deep sea.
What does the ocean smell like?
Biology.
It does
Salt.
not smell like the seashore.
No.
So just salty, or does it
Gina could
smell
probably answer
like
that best.
detritus, like decomposing organic matter, almost like a mangrove forest?
Have you been down when they're collecting samples?
I have not yet
Oh, you
been
should
there.
do that. Yeah.
Yeah.
I haven't
Jeannie?
noticed
Yeah.
any particular smell, like from the coral or any of the biology samples, but I did notice the smell from one of the Niskin blot that was released, so I'm not sure. It kind of smelled bad, actually, but
The Niskin,
well, yeah.
the water sample, huh?
So some of you have been on expeditions where we focus on hydrothermal vents. Do we ever take samples out of that, and do
Oh, yeah.
those have like,
They smell like
They're
sulfur
strong.
most of the time.
okay.
especially push cores.
So we have a former intern writing in, and they say that they smell funky like salt and weird seafood.
Yeah, weird seafood is a good.
Who's that, they say?
They didn't sign, and they're not logged in.
My
They just
money's
signed
on Peyton.
former intern.
Yeah.
Shout out to you.
Oh, yeah, holothurian right
Yeah.
there.
What do you think? Do you get some more up?
Up the slope?
Yeah.
Yeah.
How much more?
Plenty.
Which direction?
30.
Do another one?
Question mark? Sure.
Bridge
Chris
now.
Daniel is the person that's writing us in.
Cool.
Let's do one more step.
That's
Thank
great.
you.
Wow.
Thank you for your approval.
Submitting your request style. The flare.
Yeah.
It's not that the request is great, it's the way you asked it.
What's that dark stuff on the rock to the right?
I bet it's other type of rock.
Moss.
All right, zoom in, please.
Some sort of encrusting sponge or something? No,
I think it's just rock.
just rock. Rock with less sediment.
Yeah.
Okay.
Okay, thanks.
So one of our viewers is curious as to how much of the ocean is below 4,500 meters.
That's a great question.
Yeah, the average depth is about 4,000.
I know at 6,000 meters you can get to 85% of the ocean, or at least I've heard that statistic before.
So 4,000 is 50%, 6,000 is 85%. That's cool.
And the rest is Cameron depth.
That's interesting.
Cool little
Huh.
feature here.
Hot pool.
Right at the top.
Yeah.
This is where it all came from.
Let's look down in there if we can.
Yeah, I'd love to do that.
It's a lava bubble that collapsed,
The
maybe.
little rock at the bottom top up there is memorable.
Yeah, yeah. I knew exactly what you meant, but bottom top is kind of funny.
You know what I mean.
I totally do, yeah. Go ahead and zoom on the bottom top.
Yeah. Inverted zoom.
Why don't you get a sample of this crater? The absence of...
It's almost like it has a little hood over the top of it.
Can we sample this crater?
Okay.
All right, thanks. We could push core in the middle. That'd be fun. Really deep down push core.
Yeah, good
Yeah.
luck. You'd have to put the ROV on its side.
Yeah.
Okay. Yeah, this is the summit of this little knoll, and then so a little re-entrant, and then we'll be ascending the ridge, the main part of the ridge.
Yeah. It looks like this is the peak. We have peaked. There might be a little.
Doesn't get any
micro
better
null.
than this.
Yeah, this is it. This is as good as it
Oh,
gets.
it's
Oh,
not
I think
over
it
there.
gets
Our
better.
peak.
What
I
is
think-
that? Is that a Iridogorgia?
Yes.
Yeah.
Definitely some kind of gorge, yeah.
Big sea
big
star
sea star.
down there. Ha, beat you.
Yeah, you did.
Look at the black hole.
Look, we're right on it, right head on to
Yeah.
that Iridogorgia.
Now, Trevor, if you could just take one of those anemone arms and stick it in the center there and leave it there.
See what I can do.
That was a rare head-on shot there.
Yeah.
Trying to stay lined up, but it's moving around on me.
You think it's moving now? Wait till you get close.
Yeah, word has spread. Trevor's coming.
Ah!
Did you want to go to any more steps towards the knoll, or are we
It
done
has
here?
a
No, we could go west.
moray effect going on. See it?
Yeah, yeah. Cool.
Now can you kind of, yeah, let's get the side view.
Side view?
Let's
Yeah,
do a quick
just-
zoom here.
Sure.
Well,
Go
yeah,
ahead.
zoom here and then
Yeah?
kind of swivel
I'm
around.
gonna zip in for focus. Oh, that's trippy.
Oh boy.
And focus to the back, focus to the front. Oh,
I'm still moving too. So is it.
and
Can I bubble
as
on
soon as
front
we
porch,
steady
please?
up, I'm going to come out.
Avery, bubble on front porch, please. Ah, sorry, I lost it, Ed.
Oh, that's right. That's jumbo wide.
It's in the vehicle.
These things are fun to zoom on.
Yeah.
Crinoid up top.
Yep.
We're
Go
held
back
here.
in
Just
one
let me
more
know when
time.
you want to.
Disregard.
Yeah, let me know.
There we go.
Whenever you want.
All right, yeah, just kind of
Bump.
pivot to the left here and get that side view and then
Okay.
move on. 1, 2, 3, 4, 5. Okay,
Okay, thanks.
heading west.
Okay, you're
Okay.
good for a bubble.
Bridge nav. One step 40 meters, bearing 275. Thank you.
Due west.
275, due west.
It's a cardinal point.
Yeah.
Reminds me of that song by Rammstein. Due west.
Go ahead. Go ahead. 275. Yep, that's due west 275.
Which is it?
See if I can subtly get George to lose his mind.
274, please. Nope. Not due west, but 274.
So as we're making our way to the surface with the ROVs, do you ever find samples that kind of react to the pressure change by braking?
Well, the sea lily, like a crinoid that we brought up, they're very delicate. They kind of fall apart. The acorn worm fell apart.
Think that's due to the pressure or due to the sampling?
I think it's just a very delicate creature. It seemed like you got that whole acorn worm, but
Yeah,
Oh.
yeah.
in the process of maybe dropping into the box, that might.
Right.
Creates
I thought I
Maybe
remembered
because of
us opening
friction.
the box later in that dive and seeing not the full acorn worm.
Yeah.
Huh.
But yeah, it did not look. That's why the images are so important, because we get
We can
The-
rebuild him.
the sample for DNA, but in general the morphology of it looks very different on board, and then even more different once it's preserved.
The corals hold up really well. No problem with the rocks.
Yeah.
Sponges, I saw a glass sponge that was kind of looked like potato chips. down in the wetland.
Bugles. Still thinking about it.
Bugles.
Give it
Yeah.
up, Rennie.
We need to stop at a mail buoy, see if they got any bugles.
Yeah. South Pacific 7-Eleven.
Yeah.
That's so which way are you looking right now?
I'm looking north.
Oh, okay.
And we're heading west. So I'm gonna slide sideways.
Sideways.
It's more of a drop off than I thought it'd be.
Yeah.
Yeah. It's just some.
Sure does drop. Slide sideways.
Sideways.
Slide sideways.
It's already 5 p.m. on the East Coast. We're getting closer though. Well, then now we're losing daylight.
Yeah.
Not much, but
Are we?
yeah.
Aren't we south of the
No, we're north.
north of the equator, but south of the Tropic of whatever?
South of the what?
Tropic of Cancer?
No, that's
Isn't that like 15, 10?
Bridge
yeah,
now.
but that's not where you gain or lose daylight. I don't think.
Isn't it?
Add one step.
Aren't those tropics between those it's always 12 hours?
I don't know.
Days are always 12 hours? I could be wrong.
Emil might know.
Not right now. You're saying between the tropics you have what?
He's
Constant
thinking
daylight.
that you lose daylight when you're
As you go
north of
north?
the tropic. I think it's north of the equator.
Yeah, I think it's a steady loss as you go north.
Yeah.
So we're agreed that on the equator, days are always 12 hours. Is that true?
Yeah, I think you get 6 hours of. I mean, yeah,
Yeah,
6
up
a.m.
at 6, down at 6.
6
Yeah.
p.m.
Sure. I mean,
Yeah.
depending on where you are in the time zone, but 12 hours of daylight on the equator.
Right.
all
Right,
year
within
round.
that 15-degree band that is a time zone.
Sure.
Yeah.
Sure. Yeah.
But then once you go north of the equator,
You start
in the
losing.
fall, you're losing daylight.
I think it's north of the tropics. I've been wrong
Viewers, help
before,
us out
but
here. We're confused.
You might be right. But I remember someone told me that once, and
It might not be so noticeable, but I think
No, I know
you
it.
got to start losing.
Like we were just at 2 degrees south, 2 to 14 degrees south, and we were losing about 38 seconds of daylight, or gaining about 38 seconds of daylight a day.
Seconds?
Yeah.
So
In Anchorage,
days is
which
5
obviously
minutes.
is an extreme example, in the spring you will gain 6 minutes and 25 seconds of daylight a day.
wow.
in Barrow, at the peak,
Yeah.
when you're on the
The
side
maximum.
of this, yeah, it's like 20 minutes a day.
Yeah.
The
Yeah, so in
maximum's at
Anchorage,
solstice, right?
every 10 days it's another hour of daylight.
That's crazy. Yeah, the maximum change would be the solstice, I believe, or the
No,
equinox.
Yes, so the
It's seasonal.
Yeah.
side of the sign,
Side of the sign.
maximum
Sign
20 minutes.
Trying to do a satellite uplink from Alaska, sometimes you're better off to aim negative
I've
And
seen that. Yeah.
and let it bounce off the ice.
That's cool. I saw that.
But yeah,
on,
you go to
Baffin Island.
you go to Barrow, and you've been up there, right, Rennie?
I have, yeah.
Yeah, all the satellite dishes are like
angled down.
they're like aimed straight at the horizon.
Oh yeah.
Yeah, I don't remember that particularly.
They had them right on top of City Hall. They have
Just
some in
remember
the
being
gym.
very
To
cold.
get geostationary satellites?
Yeah.
Yeah. In Iceland, we were just on the rim of the useful imagery from the geostationary weather satellites.
Huh.
Bridge nav.
I always forget their
At one
height
step.
above the equator. I know it's 20,500 and something.
What is that? 20,000?
Geostationary satellites,
Ah.
miles above the equator.
Yeah.
22,500.
Durbin knows the exact number.
Exact number of geostat satellites?
Exact number of miles
Miles.
above
Of
the
miles.
equator to be
Geostationary.
They were saying
geostationary.
there's 22,000 satellites. I'm like, really?
No,
It's about
How many geostationary
36,000
satellites are there?
like
kilometers.
30. Yeah.
How many?
Oh, I don't know. There's communications, there's weather. I don't know the number. That's a lot.
I don't even know order of magnitude. Like, is it 20 or is it 20,000?
Right.
I have no idea.
You can see, I think even online, you can see a map of where they all are. I know the governments track them to avoid collisions.
Right.
That's something like 6 operational geostationary weather satellites, but there's also on-orbit spares.
I wonder how many total satellites there are. I guess operational satellites, I should say.
Well, that's the problem is if you have like 2 satellites collide, the amount of debris they create can take out.
Everything, yeah.
Yeah, there was a film that featured that. I forget what it was.
Oh, Gravity?
Maybe.
Yeah, space junk is becoming a real problem for the low Earth orbit, polar orbits. Geostationary, I don't think it's a big issue. But so to get global coverage from geostationary weather satellites, it's 2 US, 1 over Europe, spare European one over the Persian Gulf area. India's got one up there, Russia.
GOES 16, the spatial and temporal resolution on that is just
really
crazy.
nice, 16 and
it's
17, yeah.
So nice to look at.
Um,
That only
Japan
just went
has a
up
good
last
one.
year, 2 years ago, 3 years ago.
So, according to the Index of Objects Launched into Outer Space, maintained by the United Nations Office for Outer Space Affairs, otherwise known as UNOOSA, there are 4,857 satellites currently orbiting the planet.
4,800.
Increase of 4.79% compared to last year. So far, this is a year old. In 2018, UNOOSA has recorded 204 objects launched into space.
Wow. There you
So
go.
there's a number. You were somewhere in the right range.
Between 20 and 20,000.
Yeah.
Yeah, sure.
Yeah,
did get it.
5,000. About 5,000 is
Cool.
just shy of the mean.
Bridge nav. Add 1 step.
Which one of these guys do you think is going to win the race?
See, the bigger one has more experience.
Yeah, the smaller one can
Probably-
opt for rolling once they find a grade.
Navigation, whenever you have a minute, can you do a little overview of the type of geophysical surveying tools that we use here on the Nautilus?
Geophysical surveying.
You mean like the
So here they're asking if we use seismic, sonar, and this one I don't know what it is,
Oh,
MBES?
yeah MBS? That's
Multi-beam.
multi-beam echo sounder.
Oh, okay.
So we do our primary means of seafloor mapping, and in this case for pre-dive reconnaissance, would be using our multi-beam echo sounder. It's a multi-beam sonar system. It's hull mounted on the ship. Well, we can talk about multi-beam. We got a big long flat
Yeah.
expanse here. Bridge nav.
So
One
yeah.
more step. So multi-beam sonar, single beam sonar, which is kind of like the originator, is you sound an acoustic pulse from a ship into the water column, and the time of flight from that acoustic pulse from when you send it to when you hear it, and based on the sound speed of the water, you can get a range to the seafloor, therefore a distance measurement. The problem is that the way an acoustic pulse kind of propagates through the water column is you have your single point source at the ship, and then it's kind of expands into a cone shape in the three-dimensional form till it's a giant circle on the seafloor. So your resolution is that circle, which can be quite large at greater depth. So you know how long it took, how far away it is, but you have a very coarse resolution on the seafloor. That's single beam sonar. Multi-beam sonar is a really kind of ingenious way to have multiple measurements of the seafloor and higher resolution. So we have an array, two arrays of transducers. One is a transmit array, and the other is a transceive array. It's the receive, the listening. So the transmit array is oriented along the ship. So if you're facing forward on the ship, below you there's an array in that forward direction, and then perpendicular to that, a beam of the ship is the listen array. 1 second. Bridge nav.
I have an image of that here. I can
Add one
show
step.
you and potentially stream if you want.
What's that?
I have an image of those.
So the principle of it kind of works. We were talking about that single beam sonar, but if you have, turns out if you have a bunch in a row,
Yeah.
like we were talking about with that transmit array, let's just start simply. If you have two, right, then you can beamform that acoustic signal to be more of an ellipse in the perpendicular direction of your array. So I've used the analogy before that if you're at a concert and you see a stack of speakers vertically in front of you,
Yeah.
that sound is actually, the way that the wavelengths cancel each other out, it's in the perpendicular direction. So if you're looking at a vertical stack of speakers, it's actually emitting a sound wave that is perpendicular to that, like so in the horizontal direction.
Zoom on the fish, please.
Coming in. We're zooming.
That's a chimera.
Sorry. Chimera.
Yeah.
So you want to turn.
I'll keep it in frame.
Okay. Hey, Trevor, could you kind of pivot over and take a look at, or Avery,
Yeah, we're
take a look
switched
at
up
the
here.
fish? Kind of.
I can come in a little bit.
It's nice.
I'm gonna step you closer to the seafloor here. Sorry. Oop.
Turn.
I'm coming a little more on you, Avery.
Ancient chimera.
Doing fine.
I stepped you down a little bit. You're on your altitude, so you can get a little closer that way too.
Okay.
All right, now
Thank
you're
you.
falling behind a little bit, so you might want to zip ahead.
Coming out. Avery, I'm full wide.
Sorry to interrupt, Rennie.
No, no worries. That's bridge nav.
So question
Add
is...
one step. Okay, so speaker analogy. So
Yeah.
that's so if you have multiple, the more transmitters you have, the more transducers, or in this analogy, speakers you have, the thinner that ellipse is and the wider it is. So it turns from that circle sound, or that circle footprint signature, to a really wide, thin ellipse. So back to the multi-beam, so we have a transmit array of many transducers that are sending an acoustic pulse down. So now in the a beam direction of the ship, we have a super thin and wide ellipse that's painting the seafloor, but that's just a single pulse of sound. So if you take that same array and you put it sideways, which is what we have for our receiving array, then you can listen kind of in the same way that we created that ellipse with the transmit. We can listen to that small ellipse as well in the, now at this point, the along track direction of the ship. So you can think we now have two kind of a giant cross on the seafloor, and directly in the center of that, where those two meet, you have pinpoint of the distance measurement to the seafloor, and therefore we can get bathymetry. We can also steer those beams, that transceive array, and listen in certain ways synthetically that we can get a bunch of different pinpoint measurements along that transmit ellipse. So as we drive along with the ship, we have a large, we call it a swath, that's below us, that gets 200 to 400 pings, so returns on the seafloor. So those result in XYZ points, and then eventually they create a point cloud. So any amount of points would be a cloud of points. It's just kind of the vernacular we use.
Yeah.
And we can create a 3D model from that.
So you're saying
Bridge
a point
nav.
cloud is a cloud of points?
Add one step. Yeah, it's a bit advanced terminology there, Ed. I don't know if you can wrap your head around it.
Have you heard Jeff's line about that? The condescending thing?
No.
Some people say I'm condescending. That means I explain things like they don't know what I'm talking about. I love that line. Explain condescending to somebody.
So there's quite a bit of a layback, and we're approaching a slope here, just FYI.
Thanks for explaining that.
I was trying to get an image of the bottom of the vessel over here. Obviously not a live image. I took a still in shipyard, but it's hard to make it show up full screen.
So we have multi-beam, we have sub-bottom, side scan available.
It is multi-beam 432 beams on each side of the vessel, is that right?
I think, so it's 432 total, but then we can do, there's a dual ping mode,
Okay.
which involves slightly different frequencies. So you can kind of get 2 in 1 at certain depths.
Oh, I almost forgot.
It's a mushroom coral. Yeah, obviously that explanation is a lot better with visuals. But
See, I think we have some good pictures and a short overview of the imaging system somewhere in our website as well. So I'll try to find it and pinpoint everyone to it.
yeah, we're gonna hold here because we're laid back a bit and we're going up.
Oh yeah, let Argus swing.
Yeah.
Yeah, maybe we can pan around.
Another thing about multi-beam, so we were just talking about the bathymetry aspect of it, the XYZ points, but when we talk about backscatter, which is something that we keep bringing up here. That's the intensity of the return of the signal. So imagine if you have an acoustic pulse that hits a hard surface like rock, it's going to come back louder than if you were hitting something like sediment, which would absorb more of that sound and you wouldn't receive as much back. So the backscatter is a visual representation of that intensity of the return.
Seeing more fish.
Yeah, quite a few in the last couple minutes.
Yeah, so if our viewers are at home want to take a look at an image of the multi-beam echo sounder, you can go to the tab on the top of our website that says Detect, and there's a little area where it says acoustic systems, and that's going to show you a picture of what Rennie was talking about, and it has a breakdown of everything in there.
Yeah, I think Kongsberg probably has some information on their EM302, which is what we have on this ship, the EM302's multi-beam sonar. Kongsberg Marine. Mapping the Deep by Robert Kunzig has a nice discussion on multi-beam. It was originally published as The Restless Sea and then retitled when it came out in paperback, I think, as Mapping the Deep.
The first one's kind of a bit abstract. The second one's a more practical title.
Yeah.
You guys good for another step? Good? Bridge nav. One step.
And then the side scan is more of like an imaging sonar, higher frequency.
Yeah, it casts a, because of where it's located, it on the side of a subsurface that vehicle, it casts it's able to cast a shadow better, and so you can see things that are sticking out the seafloor that are taller will have what's the word? Starts with an O.
Things that are taller will have this word that you're searching for.
Not occlusion?
Yeah, it'll be occluded. Yeah.
Such an O.
Yeah.
Huh. I always thought I pictured it as starting with an E.
Occlusion.
Occluded?
Occluded.
No,
Occluded.
occluded.
Cool.
Side scan's tricky to interpret. There have been a couple expeditions in the English Channel to look for the wreck of the Bonhomme Richard, which is the ship that John Paul Jones went down on. You know, and
So you see in Argus, there's that wall.
they
coming
saw what I thought were cannons, and they were just rocks.
A little too low. Not danger low, but not bad. Are we going to shoot the gap with Argus?
Sure.
Okay.
I don't have much say in the matter.
Yeah. So another thing to watch when you're coming up on these walls is there can be stuff sticking out the top. So when you're watching Argus view, you can see the bumper bar, the two pointy bits in the front there. you can see your shadow, the distance from the rocks themselves, and you try not to run into stuff with that too. On the flats, flat mud, you'll run into the tool tray first. On the steep cliffs, you'll run into the bumper bar up top first. Yeah. I think Argus looks pretty safe. What do you think, Grady?
Yeah, I think we'll be fine. We're coming up. It wasn't like a, I don't think it's a wall. I think it's just
Just a steep slope.
steep slope, yeah.
Yeah. All right, you're getting a little ahead of me again.
Bridge now. Add one more step.
So if you see a coral or something, or if Emil asks you for a zoom, feel free to line it up and put it in frame as best you can. And then whenever you're lined up, you tell Ed when you're ready for a zoom. Pardon me? Do you want to?
So it seems like there are some viewers that just joined us recently. We're still making our way up a seamount located to the southwest side of Howland Island. We are currently looking for high-density communities focusing on coral and sponges. These organisms are often growing in high-density areas that have access to currents that can provide them with sources of food. In this case, it would be often detritus or decomposing organic matter.
Hard substrate, strong currents. So I think as we approach this ridge, that we're kind of ascending here towards a ridge, spine of a ridge. I think maybe we'll see some higher density up there.
So for those of you who want to keep up with our diving schedule and our exploration schedule, you can always tune
can see
in
your
to
track
Nautilus Live and
you're
look
going
at
this
our
way.
status on the top
Eventually you'll
of
wanna
the
bias towards
webpage.
the other way, or you're
You can
okay.
also follow us on
Let the end
Twitter,
of your tether in this
and
direction.
every time we
what I mean?
are putting the vehicles into the water, we're gonna send out a message notifying everyone that a dive is about to start.
And there was another one of those little strawberry urchins that we grabbed at the start of the dive.
Like 12 hours ago.
16.
More, yeah. Almost.
Yeah, and if you
Well,
could
that's when we
bias towards
launched.
the your starboard and go back towards the direction of where Argus is. So you want you to go like this way. That way you'll be more in front of Argus. Yes.
Oh, did I say southwest of Howland Island? We are
Yes.
northwest.
Northwest.
You said northwest side of Howland, I think.
Okay, one of our viewers heard
Yeah.
southwest.
No, we're
There
like
you go.
185 kilometers northwest of Howland. We're at, hold on, I'll tell you. Got it right here on my phone.